right, so this video is going to be about some different chord properties. So I am on page 28 in your packet. So for this first example, it says that if you have in the same circle or in congruent circles, so sometimes they're not always just one picture, sometimes it's two separate circles. But if you have two minor arcs that are congruent, then, well, it says that two minor arcs are congruent if and only if their corresponding chords are congruent. So if you have two chords that are exactly the same measure, and you know that the two circles are congruent, or if it's just in one circle like in the picture you see here, then that tells you that these two intercepting arcs are going to be congruent, okay, those two minor arcs. All right, so because these two chords are congruent, me get my line tool. All right, but because this chord right here and this chord are the same measure, then what they're telling us is that if those two chords are congruent, then those two arcs that are formed are also going to be congruent. All right, so this arc right here and this arc right here are going to be the same measure. All right, so both of those are going to be congruent to each other. So I can set them equal to each other. So I would just say 2x equals x plus 40. And for this one, I'd subtract x from both sides, and x would be equal to 40. So I would know that the measure of these arcs are 80 because 40 plus 40 is 80. 2 times 40 is 80. So 80 for this one, and then 80 for this other one. So together, 160 degrees. So some of the things that you could be asked is they may give you a picture like this, and they may only want you to solve for x. They may want to know, well, what is the measure of arc AD? And you would say it's 80 degrees. What is the measure of arc CD? It's also 80 degrees. They may ask you, what is the measure of arc AC? And remember, if they only give you two letters, then typically, you're going to go the shortest distance. So A to C would be 160 degrees. But if they asked about the major arc, there's not another point over here, but if they did ask about that major arc, then 360 minus the 160 would be 200 degrees. So there's some different questions they could ask you building off of this property. All right. Another property says that when you have a diameter and a chord, all right, if a diameter of a circle is perpendicular to a chord, so it has to form this 90-degree angle, all right, then the diameter bisects the chord and its arc. Well, if it bisects it, remember, bisects means that it divides it into two equal parts. So if we have a diameter here and we have this chord here, and it's perpendicular, well, this rule tells us that this chord is bisected. So if one part is 4, then both parts are 4. All right, so in the example, it's asking what is the measure of DC? Well, DC would have to be 8 because 4 plus 4 is 8. Now, on the flip side of that, it does tell us as well that if one chord is a perpendicular bisector of another chord, then you know that the first chord has to be a diameter. All right, so those are some things that will pop up in some of your practice problems. All right, the third example is a little bit more busy, but it says that in the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. Equidistant just means the same distance. So what that's telling us is if I know that this length right here, all right, is the same as this length right here, then they're equidistant, all right? And it's telling me that if they are equidistant, then I know that these two chords are going to be the exact same measure. So if they're both 5, if this one up here is 5, then this one down here would be 5, for example. Now let me clean this up a little bit because it's a hot mess. All right, so I'm going to go ahead and fill in some of the information that they gave me, okay? They gave me that PS is 12. Now, that's some important information, but I want to piggyback off of a property we've already learned. Notice that this is a 90-degree angle. So this is not a diameter, right? Like the property said, oh, if it's a diameter and it's perpendicular to a chord, but this little piece right here is a portion of a diameter, so we can still use that same property. And if that's the case, then we know that PS is bisected. So if the whole thing is 12, then that would mean that each little part is 6, all right? Because 6 and 6 make 12. So that's using a property from before, all right? Now it says TV is also 12. Well, again, we have this perpendicular angle right here, and we have this chord, right? And it's going from the center, so that would be like a portion of, say, a diameter. So again, that means that it's cut in half, all right? It's bisected. So if the whole thing is 12, then we know that each part is 6, all right? Well, now we know that if this is 12 and this is 12, then we know those chords are congruent. And the property here says if two chords are congruent, they're congruent if and only if they are what? Equidistant from the center. So they're telling us that SQ is 7 and they want us to find QU. Now, I don't know what QU is, but I do know that QU is congruent to RQ. All right, because if those two chords are congruent, then that means that those two pieces right here have to be equidistant. All right, so there's a lot going on. Okay, so I used the previous property that said that if you have, I'll flip back to it, but if you have a chord and it's a perpendicular bisector of another chord, or then you have a diameter, okay? Or if it's a chord and a diameter, then it's going to create that 90-degree angle and it's going to bisect the chord. All right, so when we look at this, we have a piece of a diameter. And I know it's a piece because it does at least go through the center. And it's perpendicular. That's how I knew that this chord was bisected. All right, same thing down here. All right, so that's how we knew that each of those little pieces were 6. Now, because both of those chords are congruent, we also know that they have to be equidistant from the center, okay? So we know that these two pieces are congruent. Now I need to find the measure of QU, but there's not really a lot of information there other than maybe me guessing. Like I might guess, oh, I think it's about 3, I don't know, something like that, right? But instead, we do have a right triangle right here, all right? So I can use the Pythagorean theorem, which is a squared plus b squared equals c squared. So this problem is definitely a lot more complicated. All right, so I would have 6 squared plus, we don't know squared, right? B squared equals 7 squared. And that's because the hypotenuse is 7. That's the longest side. Remember, that's always the C. So I would have 36 plus x squared equals 49. Subtract 36. So x squared is equal to 13. Square root both sides. And technically it's plus or minus, but we are dealing with length, so we would not care about the negative. So the square root of 13 as a decimal is 3.6 approximately. Okay, I'm rounding it. All right, square root of 13 is obviously the exact answer, but this length would be 3.6, which makes QU also 3.6. So there's a lot to soak in with that for sure. So what you'll do is you will finish up on page 28. There's just a few problems that you'll do. So finish up with page 28 and then submit your assignment to the Google Classroom. Thank you. Have a good day.